Hello students, the topics that we are discussing today is statistics. It's very important topic from exam point of view, either in paper 4 or in paper 6. So the topic is statistics. So under this topic, we'll be dealing with the entire kind of measure of central tendency. So the measure of central tendency means, suppose if a data is given, so we have to get the middle value of it. So there are three ways to measure. So one is called mean. So that gives you the middlemost value. The other one is called median. So that gives you a positional value or the middle one. And the third term is called mode. So all these three is the measure of central tendency. So we'll discuss all of these one by one. So let's start with the first one, which is mean. So mean is nothing in normal terms or normal mathematical terms, we say it as an average. So that means if I'm finding the mean of any particular data, so the formula is represented as x bar. So it's given as sum of all the values of x divided by the number of observations, which is n. Now, for an example, if I give you the numbers, say 1, 2, 3, 4, 5, and I ask you to get the mean. So according to the formula, we have to add all the numbers 1 plus 2 plus 3 plus 4 plus 5. And since there are 5 numbers given to, so I have to divide it by the number of numbers, which is 5. So I'll add 5, 4, 9, 9, 3, 12, 12, 2, 14, and 14 and 1, 15. So I got 15 by 5, and that's equals to 3. And as you can also see that 3 is the middlemost value. That's for what mean is known as the measure of central tendency. That means it gives us the middlemost value of the distribution. Now, this is for discrete random data, and that's the formula that we use to calculate the mean of any distribution. Now, data can be discrete or continuous. So continuous data, which literally means that the frequency is also given. So that means if we have some like this, where you have the x values and you have the frequency given to you. Frequency means the number of times a particular value is repeated. Suppose it's 1, 2, 3, and 4, and the frequency is 2, 2, 1, and 2 for an example. So the first column that we need to find is f into x. That means you have to multiply these two values. So that's 2 into 1, 2. That's 4. That's 3. And that's 8. Now, we have to add all the frequencies. So the sum of the frequencies is 7. And then we have to add all the values of f into x. So that's 6, 3, 9, 8, 17. So the value for the formula for x bar in terms of frequency is summation of f into x divided by the sum of the frequencies. So that literally means here if I'm doing f into x, so the summation I got is 17, and that's by 7. So that's the value of my mean for this particular distribution. Now, there are various other types of questions asked with respect to mean. The other one can be that you have a class distribution given to you, and then you have to calculate the mean. So this type of questions are usually a 4-marker in paper 4. Now, suppose you have a class interval given to you. So class interval literally means just like we can say x is greater than equal to 0, less than equal to 20. We can say x is greater than equal to 20, less than equal to 40. We can also say like x is greater than equal to 40 and less than equal to 60. And x is greater than equal to 60, less than equal to 80. So as you can see, it's a continuous data distribution, but defined as a class. Now, the frequency will be given to you. So the frequency here is 4, 2, it's 3, and it's 4 again. Now, in this case, you have to first get the middle value of x, or middle value of class, and that will be treated as x. So how do we get the mid value? So if I want to get the mid value, so I'll take, this is called lower boundary of a class, and this is called the upper boundary of a class. So if I have to get the middlemost value, so that means I have to do lower boundary plus upper boundary divided by 2. So in this case, I get 0 plus 20 divided by 2, so that's 10. So the middlemost value for this is 10. Similarly, if I want to get the middlemost value of this. So it should be 40 plus 20 divided by 2. So that's equals to 30. Then again, I can take 60 plus 40 divided by 2. So that's 50. 80 plus 60 is 140 divided by 2. So that's 70. Now, once I got the middle value, so the another column that I need to make is f into x. That means 4 has to be multiplied by 10. So that's 40. 30 has to be multiplied by 2. So that's 60. 50 into 3 is 150. And this is 280. So I'll have to get the sum of f into x. So that's 100, 250, and 280 is 530. Similarly, I have to get the sum of the frequencies. So that's 437 to 9, 4, 13. So in this case, the value of my x bar or the mean has to be, again, summation of f into x divided by the sum of the frequencies. So that is equals to 530 divided by 13. So that's how we calculate for a given class the midmost value. I'll give you a minute to note this down. So these are the kind of variances that's been asked so far in mean. Now moving ahead to the other part of the measure of central tendency, which is called median. Before that, we'd like to know that what happened to the mean that we shifted on to another measure of central tendency, which is median. So in other words, we are asking about the drawbacks of the mean, right? So if I'm talking about the drawbacks of the mean, so the one drawback which mean has that it has a tendency to move towards the larger number. That means if I'm finding the mean of 1, 2, 3, so the middlemost value, the mean will be 2. But if I'm finding the mean of 10 to the power 7, so mean will have a tendency to move towards the larger number. So if there's a larger number that goes on and on like that, so the smaller numbers, which is a part of the set, will not be even accounted for. So that's one of the drawbacks of the mean, that it has got a tendency to move towards the larger number. So that's the drawback. So we shifted on to something which is known as median. So moving ahead to ask what the median is. So median is the positional value of the data and gives us the midmost thing. So suppose if we have numbers like this, so say suppose 22, 15, 7, 8, 10, 12, 13. We have 6, we have 3, we have 2. So first of all, we have to arrange all of these numbers in the ascending order. So step 1 is arranging these numbers in the ascending order. So start from the lowest one and move on to the highest one. So it's 2, 3, then the number is 6, then it's 7, then it's 8, then it's 10, then it's 12, then it's 13, then it's 15, and finally it's 22. So we'll now count the number of numbers. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here n equals to 10, and that's an even number. So step 2 says, if n is even, so n by 2th and n by 2 plus 1th term mean will give us the median. So what does that mean? So that literally means since here the value of n is 10, so n by 2, so that is equals to 5th term. And if I'm talking about n by 2 plus 1, so that literally means it's the 6th term. So I'll check out. So see, this is first term, second term, third term, fourth term. Now that's my 5th term and that's my 6th term. So I will take the mean of these two. So that means 8 plus 10 divided by 2. So the median of this distribution has to be 9. So the median here is 9. Now, the other method, which is used to find median in case of even numbers, is I can divide the numbers into 2 equal groups, right? So it's 5 elements each here. So again, the middlemost value here is 8 and 10. So that literally means we can again find the mean and 9 will be our median. So this is called grouping method. Now moving ahead with the other type of variation, Suppose the values of the numbers are odd. So in that case, what we can do? Now, again, we'll illustrate it with an example. Suppose we have numbers like 2, 5, 7, 9, 11, 13, 22, 15, 25, 31, and we'll count them. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. In this case, the number of observations is 9, which is an odd number. So what we can do is here. So step one, again, we have to put the numbers in the ascending order. So that's the numbers that we have put in ascending orders. Now, step two, if n is odd, so we say that n plus 1 by 2th term will give me the median. So what does it mean in this case? So in this case, since n is 9, so n plus 1 by 2, so that's equals to 10 by 2. So that is equals to 5th term. So that means the 5th term will be my median. So 1, 2, 3, 4. So that's the value of my median, which is 11. So that's how we work it in case of odd numbers. All of you, I'll give you a minute to note down for mean and median. So now moving ahead, we'll discuss something which is known as stem and leaf plot. Now, median is also found out for the continuous data. Now, that we'll be discussing in cumulative frequency graph. So the final measure of central tendency is known as mode. So what do we mean saying mode? So mode is the number which has got the highest frequency. If in a distribution, something is repeated quite commonly, that means it has got highest number of repetitions. So we take that as a measure of central tendency. Just like for an example, if I have x values and frequency values and the numbers of x are 1, 2, 3, 4. So this is 2, this is 3, this is 5, this is 9. Since 4 is repeated for the most number of times, which is 9, so the mode of this distribution should be equal to 4. So please remember that's a number which is repeated for the most number of time is known as mode and is the measure of central tendency. Now, moving ahead from here, as we told, we'll be going to something which is known as stem and leaf plot. So how does a stem and leaf plot work? So the topic is stem and leaf. Now, in stem and leaf graph, it's just a representation or rather a diagrammatic representation of the data in ascending order. Suppose we have data like this as 6, 7, 10, 11, 13, 15, 22, 25, 29, 31, 35, and we ask you to draw a stem and leaf plot. So step one again says you have to put up in the ascending order. So the step one is always you have to put data in the ascending order. Ascending order literally means that you have to start from the smallest data and go to the highest. Here we have already arranged the data in the ascending order. Now, if now I want for the step two, so we have called something which is called key. Key is that helps us to draw a diagram. So that means suppose if I want to write 6, so I'll write 0 here and 6, and that's equals to 6. So that's how a key is presented. And we have to draw that key so that we know what type of distribution it is. So if I draw a line, so this part is called stem. And this part is called leaf. You don't need to write stem and leaf. It's just for the illustration. So suppose if I write 0, so that's 6, 0, 6. That's represented like that. Then I can write 0, 7. Now to write 10, so I'll bifurcate it according to the key. So 1 will be written here. 0 here again, so 11, so that's 13, that's 15. Again, I bifurcate 22, so that's 2, that's 5, that's 9. Again, I write 3 here, so that's 1 and that's 5. So that's how we plot a stem and leaf thing. Now, if I have to find the mean, or if I have to find the median in there, so the method remains the same as counting the number of numbers, whether n is even or odd. Depending on that, we'll find the median as we have already discussed before. So this is how we go for a stem and leaf plot. Now, we have a part of stem and leaf which is called back-to-back stem and leaf plot. So if I'm going for something which is called back-to-back stem and leaf plot, what does that mean? So that literally means that suppose if there's two sets of data given to us, right? So that means suppose if I'm writing as 1, 0, and 1 like that. So if I take for the key for this, so that represents 1, 0, 10. And if I'm taking a key for this, so that represents 0, 1, which is 1. So this is what we say is a stem back-to-back stem and leaf plot. Suppose we have data for boys and data for girls. So for boys, we have say 6, 8, 10, 12, 15, 19, 22, 25. And for girls, we have 3, 5, 9, 11, 13, 16, 24, 28, like that. So if I'm drawing for the back-to-back stem in the first, so the middle line will always be for the stem. So that means if I'm writing 0 here, so that's for girls and that's for boys. So boys, for if first I'm writing for boys, so 0, 6, now that's the key that tells us that it's 6. So I can say 0, 8, I can write 1 here. So that means I can, for 10, I can write this is 2, this is 5, this is 9. I can put 2 here. So that literally means this is 22 and that's 25. Now for the girls, if I'm writing, if I have to write 3, so that means I have to make a key that 30 is 3 here. So that means 50 will be 5 here, 90 will be 9 here. So 1, so that's 1. So that's 3 here. So 3, 1 will give us 13. That's just like the reciprocal of the mirror image. So we can say 6, 1 gives us 16. So that's if I want to write, so that's 2, 4, and that's 2, 8. So this type of diagrammatic representation is known as back-to-back stem and leaf plot. Now, coming to something which is very commonly asked, and it's a very, very vital part of IGCSE extended, is box and whiskers plot. So a lot of questions are asked on box and whiskers plot. So how does a box and a whisker plot look like, first of all? So it's again a diagrammatic representation of a data which has to be in an ascending order or to be in an order. So, yeah. So this is the lower bound, and this is called lowest data value. That means in the distribution, the one which has got the lowest value will be placed here. This part is known as first quartile. This part is also known as median or known as second quartile. You can also write it as Q2. This part is known as third quartile, and this position gives you the highest data value. So I'll give you a minute to write down this representation along with what does it mean. So all of you would have written this down, the diagrammatic representation of box and whiskers plot. So now we'll discuss a sum that how does we plot a box and a whisker plot. So now, suppose any random data distribution is given to us. So it's 22, 15, 13, 6, 8, 9, 2, 5, and that's 31, something like this. So as I said, step 1 will always be to put it into the ascending order. So that means we'll start from the smallest one, which is 2. After 2, the second largest one we can see here is 5. Then we have 6. Then we have 8. Then we have 9. It's 13. It's 15. It's 22. And the largest one is 31. So step 2 is to count the number of data that we have. So that means I can say 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know that the value of n is 9. So if now I have to get the median, So that literally means that median has to be n plus 1 by 2th term. So that means 10 by 2. So that has to be 5th term. That's my median. So that means the median of this distribution is this. Now, step 3. If I need to get the quartile, the first quartile. So see, excluding median, I can put it into two groups which has equal number of elements. Now, the first quartile is nothing but the middlemost value of the first group. So to get the middlemost value of the first group, which is first quartile, we have to get the mean of 5 plus 6 by 2. So that's equals to 5.5. So that's how we get the value of first quartile. Now, if I want to get the value of third quartile, so that's something the middlemost value of the second group, which is 22 plus 15, and that's divided by 2. So that's equals to 37 over 2. So that's 18.5, and that's my third quartile. So if I have to find interquartile range, which is called IQR, so the formula is third quartile minus the first quartile. So in this case, it has to be 18.5 minus 5.5, and that's equals to 13. So that gives us the interquartile range. If I want to get the range of this distribution, so that means I have to do highest value minus the lowest value. So in that case, it's 31 minus 2, and that's equals to 29. So if I have to represent this on a box and a whiskers plot, so I'll draw a box plot like this. Now, at this point, I'll place the lowest data value, which is 2. Here, I'll place the highest, is the lower quartile, which is 5.5. Then I place the median. So the median that we got fifth term, so that's 9. Then here I'll place the third quartile. I can place the highest data value, which is 31. So that's how a box and a whisker plot is constructed. Now, most of you would have been thinking that since it was an odd number of distribution, so we were able to get Q1, Q3 by grouping method. What happens if it's an even number of distribution? So we'll discuss that also. I'll give you a minute to note this down. So yes, all of you would have written this down. Now we'll discuss a sum where the number of elements are even. So suppose if we have a distribution which is already in the ascending order. So we have 2, 3, 5, that's 11, that's 13, so that's 15, that's 17, that's 22. So if we stop here, so we have the number of elements which is n equals to 8, and that's even. So first we'll divide it into two groups. So now if we have divided into two groups, so we can see that there's no space for the median here. So for the median, we need to calculate the mean of these two. So if I'm calculating the median or the first or the second quartile, so that has to be 11 plus 13 divided by 2, and that's 12. So my median is 12. Now, if I want to get the first quartile again, so I have to get the mean of these two because this will give the middlemost element. So that's 3 plus 5 by 2. So my first quartile has to be 4. If I'm finding the third quartile, so that has to be 15 plus 17 divided by 2. So that is equals to 32 by 2, and that's 16. So that's the value of my third quartile. If I have to get the interquartile range, so that has to be Q3 minus Q1, and that's equals to 16 minus 4, and that's 12. Suppose if I have to get the range of this distribution, so that has to be highest value, which is 22 minus 2, and that is equals to 20. So that's the range of the distribution. So I'll give you a minute to note down this problem as well. So hope all of you would have written that. So now we are moving on to the diagrammatic representation part of statistics. So that means we have to represent the statistical data in the form of diagram. So the two most common things that's used for doing that is called pie chart and histograms. So both of them are very important part of IGCSE extended, both paper 2 and paper 4. So first of all, we'll discuss it one by one. So first, if I'm discussing something which is known as pie chart, so that's a circular kind of chart that used to represent the data and as a part or as a proportion of a circle. Suppose if I say that A equals to 60% of the distribution, B equals to 30%. and C equals to the remaining 10%. Now, if we're representing this in the part of percentages, we need to make sure that the entire distribution should be 100% thing. In that case, we'll first calculate that what part of a circle will the 60% be. So that literally means in a full circle, we have 360 degrees. So 60% means 60 by 100 of 360 degrees. So that means we can cancel out zeros, and that is 36 into 6. So that's 216. So that's much degrees will be occupied by A. Similarly, if I'm talking about B, so that has to be 30% of 360 degrees. So again, we can cancel two zeros. So that's 36 into 3. So that's 108 degrees. And again, it should be 10% of 360 degrees. So we can cancel this out. And this is equals to 36 degrees. So again, we have a second checkpoint. That means 216 plus 108 and plus 36 must give us 360 degrees. So we'll check out that 216 degrees plus 108 degrees plus 36 degrees should give me a total of 360 degrees. So that's the checkpoint. Now, how to draw a pie chart? So that literally means we'll draw a circle. Now from the center here, we need to draw 216 degrees. So that means if I'm drawing this line for A, so this dot, the line below will give me 180. So a bit more than that. So that is something which we can see as 216 degrees. So that is something for A. Now, similarly, we have to plot 108 degrees. So obviously 108 degrees will be greater than 90 degrees. So that means this is somewhere where we can say it as 108 degrees, and that's for B. And the remaining 36 degrees is for C. So this is how we plot a pie chart. The given percentage or the ratio of the numbers are given, or the percentage are given. So we calculate them through degrees and put it onto a circular diagram. I'll give you a minute to note this down. So hope all of you have written this down. Now moving ahead with the second type of questions asked on pie charts. They'll give you the pie chart, which is drawn here, and they'll ask you to find the percentage. That means the reverse process. So that means suppose they'll give you the pie chart and they say that this is 90 degrees and this belongs to A. Say suppose this is 110 degrees and that belongs to B. And this is the remaining, which is 160 degrees, and that belongs to C. So what is the percentage occupied by A? So if I have to get the percentage occupied by A, so the formula has to be the degree which they have given, 90 degrees, divided by the total, which is 360 degrees, and that's into 100. So that means I can cancel, this is 4. And this is equals to 25%. So A occupies the 25% of the distribution. If I have to get it for B, so that's 110 and that's 360 and that's divided by 100. So that means I can simply calculate this value. So that's 1100 by 36, and whatever we get, that percentage should be occupied by B. And for C, it should be 160 over 360 into 100. So yeah, again, we have 1600 over 36, that much percentage is occupied by C. So this is the other type of questions in which you have the pie chart given to you, and they ask you to calculate the percentages for A, B, and C. So I'll give you a minute to note this down as well. So I hope everyone would have noted this down. Now, the second diagrammatic representation part for IGCSE Extended is histograms, and it's very, very important part of the paper, both paper 4 and paper 2. So now, how does the histogram looks like? So let's do it with a sum. Now, suppose if you have a class width, or rather a class interval given to you. So here we say that suppose x is greater than equal to 0, less than equal to 20. Here we can say that x is greater than equal to 20, less than equal to 30. We say that x is greater than equal to 30, less than equal to 50. And again, we say that x is greater than equal to 50, less than equal to 75. So that's what we say as a lower boundary of a class, and that's the upper boundary of the class. Now, That means the second thing that, and they'll give you the frequency, which is given. Say, suppose this frequency is 5, that's 10, that's 20, and that's 30. So that's the frequency that they have given. So the first thing that we have to calculate is called class interval. So the formula for the class interval, or this is even known as class width. So both of them are same, either the class interval or the class width. So these terms in case of histogram is same. So that means we have to do lower boundary minus the upper. So that's 20 minus 0. So that's 20. 30 minus 20. So that's 10. 50 minus 30. So that's 20. And 75 minus 50. So that's 25. Now we have to get the formula for frequency density. Now that is something which is given as frequency divided by class width. So the formula for frequency density is frequency divided by class width. So if you're calculating the frequency density, so in this case, it becomes 5 by 20. So that's 0.25. In this case, it's 10 over 10. So that's equals to 1. In this case, again, it's 20 over 20, and that's equals to 1 again. And this is 30 over 25. So that means that's 6 by 5. And that is equals to, say, approximately 1.2. So if now I'm plotting the histogram, so across the x-axis, we have class, that's the x values, and this is frequency density across the y-axis. So if I start from 0 and end up till 20, so I have to plot frequency density, which is 0.25. So I have to plot something this, which is 0.25. Now, as for the second one, from 20 to 30. So that means I'll go from 20 and it goes on till 1 because the frequency density is 1. So it is something like this from 20 and will end at 30. Again, from 30 to 50, the frequency density is 1 again. So that's 20 over 20. So that means from 30 to 50, again, the frequency density is 1. Now, if we look from 50 to 75, that means I have to extend this, and that is 75. So that's 1.2. So that literally means that's how we plot it, and this value is 1.2. So that's how an histogram is plotted from the given data from the class interval. I'll give you a minute to note this down. So I hope all of you would have written this. So now, other important part, if I join the midpoints of these vertical bars through a line, so I'll get a line figure like this. So this figure is known as frequency polygon. So this is called frequency polygon, or even in statistics is known as ogive. So if they ask you to draw a frequency polygon or an ogive, you first have to draw the histogram and join the midpoints of the vertical bars to get that line diagram, which is known as frequency polygon or ogive. So please note this down. Now moving ahead from here, we go to something which is known as cumulative frequency graph. So this is how we draw for a cumulative frequency. Now that's very, very important part again in statistics, and that's quite commonly asked in paper 4. So if I'm talking about the cumulative frequency graph, so we have x values and we have the frequency values. Suppose the x values are 1, 2, 3, 4, 5, 6, and the frequencies are 1, 2, 2, 1, 2, 2. So the first thing that we'll be doing for the cumulative frequency of less than type, the first frequency will be written as it is. So that's 1. Then to write the second frequency, 2 gets added to this, so it becomes 3. Again, 2 gets added, so it becomes 5. Again, 1 gets added, so it becomes 6. Again, 2 gets added, so that's 8. And again, 2 gets added, so that's 10. So this is what we say as capital N, and is denoted as sum of the frequencies. That means if I'm adding all the frequencies, I should get 10. So that's the checkpoint for cumulative frequency graph. So if you're plotting this particular graph on the graph paper, so that's your X value and that's your CF, or the cumulative frequency value. So the values that we get is a kind of S-shaped curve. So that will saturate it at 10 because that's the value 10 here, which we got here. That's 10. Now, if I ask you to find the median for this cumulative frequency graph, so the formula is n by 2. So in this case, it has to be 10 by 2, which is 5. So that literally means from the 5 here on the cumulative frequency, we'll drop a line on the S-shaped curve, and whichsoever part it touches on the x-axis, that will give me my median. So in this case, we say it as 5, and 5 is here for cumulative frequency. So we can say that the value of x is 3. That means the point where it is cutting here, that's 3. And that's the median of our distribution. Now, if I ask you to calculate the first quartile, so the formula is n by 4, which is 2.25. So if I look at, not it's 10 by 4, so that's 2.5. So if I look at in the cumulative frequency, so 2.5 should lie here because it's greater than 1. So the respective x value, so this is my first quartile. So that means from here, if I'm drawing from 2.5, the line on this, so I'll get it at 2. That's my first quartile. Similarly, if I want to get the third quartile, so that the formula is 3n by 4, and that gives me 7.5. So if you look at cumulative frequency, 7.5 is greater than 6, so should lie here in A. And the respective x value, so this is my third quartile. So that means from 7.5 here, if I drop a line on the S-shaped curve, so the respective x value should be equal to 5. So that means my median value is equals to 3. My first quartile value is equals to 2. And my third quartile value is equals to 5. So if I'm finding IQR, that's interquartile range, should be Q3 minus Q1. So that's 5 minus 2, and that's equals to 3. This is very, very important calculation asked in almost of the papers of IGCSE Extended 4. So I'll give you a minute. Please note this down. So I hope all of you would have understood how to go for the cumulative frequency graph. Now, we are moving on to the final part of the statistics, which is we say as a scatter plot or the line of best fit. So a scatter plot is simply a graph of x and y. So that means the points of x and y will be given to you, say 2, 5, 7, 9, 10, and we have 3, 10, 12, 15, 17. So that means we have to plot these points on the graph on the axis, which is this is your x-axis and that's your respective y-axis. So you have to take these coordinates like 2, 3. So that literally means the x value has to be 2 and the y value has to be 3. So you have to plot those points on the graph. If the trend of the graph is a straight line like this, so the angle measured from the positive direction of x-axis taken anti-clockwise is positive. So this type of correlation is known as positive correlation. What does a correlation mean? So that literally means depending upon if x increases, so whether y increases or decreases. That means the relation between the two variables x and y. So if it's a straight line like this, so that's called as positive correlation. If there's a straight line between x and y, that gives you a trend something like this, which is going down. So that's called negative correlation. So that literally means if the value of x increases, the value of y decreases. So that's the reciprocal. And in this case, if it's a positive correlation, so if the value of x increases, so the value of y also increases. On the other hand, if you get a plot like this, where the dots are very different and you don't have any kind of straight line pattern. So if it's the dots are scattered all over the places and you don't find any kind of linear pattern, so this is said to be as no correlation. So that means there's no relation between x and y. So that means if x increases or y decreases, there's no effect on x and y. Please note this down. I'll give you a minute to write this. So all of you would have written this. Now we are discussing the final part of statistics, which is called line of best fit. So that's how it works. Suppose we have x values given to us as 2, 5, 6, 7, 8, 9, and we have y values, which is again 3, 4, 5, 6, 7, 8, like this. So we have to first find the mean of x values. So that means we have to add all the x values. So 2 plus 5, 7, plus 6, 13, 13 plus 7, 20, that's 28 and 9. So that's 37. Now, the number of observations is 6. So that's 37 by 6. So that's equals to approximately equals to 6.2. Then we'll have y bar. So that means we'll add y values. 3 plus 4, 7, 5, 12, 6, 18, 7, 25, and 8. That's 33. So that's 33 over 6. So that's approximately equals to 33 over 6. So that's 5.6. Now, once we are plotting the scatter plot, so that means this is my x value, that's my y value. So let's scale it for x, y, and so that's 1, 2, 3, 4, 5, 6, 7, and we extend it to 8. So that's 8, 7, 6, 5, 4, 3, 2, 1. Similarly, we extend it across the y-axis. So it's 1, 2, 3, 4, 5, 6, 7, and 8. So yeah, so that means that's 8, 7, 6, 5, 4, 3, 2, 1. Now, the first point is x coordinate is 2 and y coordinate is 3. So that means the point should lie here. So we can just plot that point. Now that's x is 5 and y is 4. So that means if I plot x is 5 and y is 4, so that's a point which should lie somewhere here. So again, we have x as 6 and y as 5. So we have x value as 6 and y value as 5. So that is a point which is somewhere here, 6 and 5. Now we have 7 and 6. So that means 7 and 6 is a point which is here. Now we have 8 and 7. So that means the value of x is 8 and this is 7. So that's the point which can lie here. Now we have x is 9 and y is 8. So that means we have to extend this to 9. And then the value of y is 8. So as we can see that if we're plotting this plot, so we're getting a kind of linear pattern, which is this. So that literally means it is a positive correlation, as I was talking about earlier. Now, in this part, we have to plot for the mean that is 6.2 and y is 5.6. So that x value is 6.2 should be somewhere here. And y value as 5.6 should be somewhere here. So that's 6.2 and 5.6 is the mean point. So that's the point where x bar and comma y bar. So now if I draw a line which is passing through the mean and touching these points, so this line is called line of best fit. So please remember, to calculate the line of best fit, we need to calculate the mean of x, mean of y, and then plot it on the scatter plot and draw the line which passes through the mean itself. And that's the line of best fit and the correlation analysis. So this is how the entire statistics part has been done. So we wish you all the very best in IGCSE examinations. If any doubts anywhere, do feel to reach out to us. We'll be eager and happy to help you out. So all the very best for your examination. Thank you.